Hello everyone. So in today's video, we will try to figure out how does this work. So I will show you a code snippet, and you have to guess the like output of that code snippet, and then you like I will tell you whether it was right or not, and why it was the way it was. Okay. So as you can see on the screen that this is a code snippet, and nothing complicated, just simple three console logs are there. One console log is inside the set timeout. So guess the output. I hope you did that, and let's try to run the code. Node quiz, and first, third, and second. And I'm sure most of you probably got this right. Okay, because nothing complicated about it. Because you might think that there is 1,000 milliseconds, so it's supposed to wait that much time. And first, second, third one gets printed second, and then the second one is after 1 millisecond or 1 second. All right. But what happens when I change it to zero? What do you think will happen now? Now you guess the output, and let's try to run it again. And as you can see, first, third, and second is still the same output, even though I changed it to 0 millisecond, which means don't wait, just it's like immediately. But it still is waiting, like getting printed after the third one, which is on the last. And this is the part that we need to understand about, as how does JavaScript works behind the scene. All right, so let's try to understand that. And for that, I have made this diagram. I know it's not an actual event loop diagram, but the concept that I will teach you, it will help you in understanding that. So what is that? JavaScript runs asynchronous tasks very differently, and in JavaScript asynchronous tasks go through a very specific process before they run. Okay, so let's try to understand that. Well, JavaScript first runs all the synchronous tasks from top to bottom, and this happens in the call stack. I hope you know that, which is a part of JavaScript engine. And first it will run all the synchronous tasks, right? So that's your first answer. And then what happens is, whenever set timeout, set intermediate, or set interval, or fetch promises, or and DOM related things, any of these things, whenever JavaScript encounter them, it thinks that okay, it's not my part, it's the web API's job. So it hands to the browser web API, like, hey, deal with it. That's it. And then what happens is that once the web API is done with its task, it puts them into the call stack queue. Well, sorry, not callback queue, that you can see on the like this example also. That this is where this get puts all the, like for example, set timeout after certain millisecond, it will push that call a function into this queue. That okay, now you can get executed, like it's your work is done. But event loop will constantly checking that okay, call stack is empty or not. As I said, JavaScript runs synchronous task before any of the tasks. All right. So first it will execute all of those synchronous tasks, and once they are done, meaning call stack is empty, then event loop what it will do, it will constantly checking both of them, call stack and callback queue. And web API or asynchronous tasks are done, they gets pushed into this callback queue. And from this queue, event loop will pick these callback functions and put them into the stack for the running. Like now you can execute them. So this is why when we say that, even though we did the 0 millisecond for that, but still, as I said, asynchronous task goes through a special process, which is it will go through the web API, and then web API will do the like wait for that time or whatever the task was, and then once its work is done, it will push that callback function. That for example, in this inside the timeout, we have this callback function, right, where we wrote the console.log. So instead of this console.log, it will put that entire callback function into this callback queue. And once the while and while this happening, event loop, it will keep checking whether the queue is empty or not, or stack is empty or not. Once there's something inside the callback queue, it will check okay, is call stack now empty, meaning all the synchronous tasks are done. Then pick up that from the callback queue and put them into the call stack. Now you can run. So that's why even though it was 0 millisecond, it will still all those console log outside the set timeout were called synchronous, so they were run first. No matter how fast that asynchronous task was, it will still get done after that uh, synchronous task.